Hi, Morgan here for Onefinity, and today we're going to cut one of these here Viking chairs on the CNC. A Viking chair is a simple, cheap piece of outdoor furniture that packs flat and goes together without any tools for camping, kids' soccer games, or I don't know, any situation where you're outside and you want to be sitting. It's great for that. This may seem like a really straightforward project, but here's the cool thing about it. These chairs are in two parts. Both of them are 42 inches long, and they were both cut on my 32 by 32 Elite Woodworker. So in this episode, we're going to cover how to toolpath, position material, and cut parts diagonally so you can exceed the standard X and Y axis limitations of your machine. Pretty cool. So let's get into it. I started by designing this thing by defining the limitations of the machine. So I drew a square vector that was 32 inches by 32 inches, knowing that the parts would need to fit within that space. The maximum capacity of a woodworker is 32 inches by 32 inches, but from corner to corner, it's actually 45.2548 inches. That's a huge difference. So whatever the rated capacity of your machine is, you've actually got more room than you think. Anyway, we're going to design this thing within the confines of our known space, rotated at 45 degrees. The two parts of a Viking chair are the back/front leg and the seat/rear leg. The widest part of both parts of the chair are 12 inches, so I'm extending 6 inches out in both directions from that center line. And you'll see we start to go out of bounds closer to the corners, so I'm going to round off the top of the back. I think that looks nice anyway. Moving down to the legs, I don't want the edge touching the ground to be flat just in case I'm sitting on an uneven surface. So I cut into the middle of that edge a little bit to create two legs. After I cut the front, I'm gonna flip the workpiece over and cut some stuff on the back that'll be used once it's finished to keep the two parts together for carrying around. To keep everything aligned, I'm gonna put all of my vectors in one part in one place, then just copy and paste them for the other part. I put engravings on these things because I wanted to make a his and her set. The engraving is totally optional. I just thought that would be fun. So I'm going to cut 4 pockets along the center line, 2 for magnets and 2 for dowels. The magnets are there to keep the two parts together, and the dowels are to prevent them from shifting or sliding off. I measured the diameter and thickness of the magnets and toolpathed the magnet pockets accordingly. Then I used a caliper to measure the diameter of my dowels. If you buy a dowel and the sticker on it says that it's a 1/2 inch diameter, ignore that. It's not. Then this last pocket here is for a bottle opener. Obviously, it's a camping chair. All right, you'll notice 3 open slots. 2 of those are going to be handles for carrying it around, and the other horizontal slot is where the seat and rear legs slide into. This part you'll need to pay close attention to because of the dimensions are dependent on the thickness of your material. I made mine out of just regular old 2x4s from the home center. After flattening, gluing them up, planing them down, I ended up with 1 1/4 inch thickness. So that's the measurement I used for the mortise. The seat is the same width as the back, and it'll stick out by 12 inches as well. The rear leg cuts in by 2 inches on each side, making it 8 inches wide. To make sure that the magnets and dowels on both parts line up, I just copied and pasted the whole vector, then just swapped out the vectors specific to one part for the other. All right, now that we have all of our vectors, let's get this thing toolpathed. I'm going to open Carveco and create a new project, with my work origin set to the machine's default home position. We'll start with the front-facing side of the back. I'll go ahead and knock out that Queen design. These are big block letters, and I don't want to do an engraving toolpath with a V-bit. That would just take forever. So I'm going to use a V-bit, but instead of an engraving toolpath, I'm going to run this as a profile toolpath cutting along the vectors. That'll make the design clearly visible without clearing out all the waste inside the lines. It's just way faster. I'll set the depth to a 1/16 of an inch, and with a spindle speed of 20,000 RPMs at a feed rate of 150 inches per minute. All right, that takes care of the front. Let's go ahead and toolpath the back. We're going to do 4 pockets in 2 toolpaths, all with an 1/8 inch spiral bit and the same feed rate and speed settings. The first 2 are for the magnets, using the measurements I took with the caliper. Those will be 0.1 inches deep and 1.165 inches in diameter. Odds are whatever magnets you use aren't going to be the exact same as mine, so just make sure to measure yours and adjust the vectors and toolpath accordingly. Then we'll measure the dowels and do the same thing. Like I said earlier, wood dowels are rarely the size they're advertised as, so again, measure and adjust accordingly. Next, we'll go ahead and cut these 3 slots. They're through holes, so it doesn't really matter if I do them on the front or the back. For those, we'll do a profile toolpath with a 1/4 inch end mill. And we'll do those with the same 1/4 inch end mill at 20,000 RPMs and 150 inches per minute. I'll be securing my parts to the wasteboard with CA glue and blue tape, so I don't need any mechanical work holding, but If you're just using hold downs around the edges of the part, you'll want to add some bridges to keep the waste inside those slots in place. After those are done, I just make one profile toolpath cutting outside the vector to cut the whole thing out of the large piece. Again, the material is 1 1/4 inches thick, so that'll be the depth of the cut, and I'm using a 1/4 inch end mill. All right, one part down, one to go. The next part will be for the seat and rear leg. On this one, the process will be largely the same, except we don't need to flip this one over. So we're looking at the back of the part. For the magnets and dowel pockets, we're actually just going to use the same toolpath that we used for the first part. That'll make sure the locations are consistent and will line up once we start putting this thing together. Then all we need to do is run a profile toolpath to cut it out. All right, now we have all our toolpaths. Let's get the machine set up. This is where you're going to want to pay close attention to how you position the material. The grid of tracks on my wasteboard were cut by the machine, so I know that they're perfectly parallel with the X and Y axes. Knowing that, I drew a line from corner to corner, and that'll line up with the dead center of the workpiece. With the center of the workpiece lined up with that diagonal center line, I'm going to glue down some stops so that when I flip it over or swap out material, it'll all sit in the same position on the wasteboard every time. We're going to put a 60-degree V-bit in the spindle, probe for Z, load up our first toolpath, and run it. Now we can flip the material over and get the other side. Secure the material back to the wasteboard and run the toolpath for the magnets and dowels. Now let's change to a 1/4 inch spiral bit, probe for Z again, load up the toolpath for the 3 slots, and fire away. And now we just got to cut the whole thing out. So we'll load the program, and here we go. Cool. Now I'm gonna load up my second panel, a little bit of CA glue, a little bit of accelerator, and there we go. Secure it to the wasteboard and run the magnet and dowel toolpath again. Piece of cake. Now we'll just cut the whole thing out with our last toolpath. And there we go, all done. Once I had both parts off the machine, I brought it over to the router table to give every edge a nice, subtle 1/4 inch round over. I gave it a light sanding, my favorite part of the process. Now we can glue in our magnets with some super glue, then glue the dowels into the back part with some wood glue, and wait for it to dry before sticking them together. You got to put the dowels into the back part because the other part, the one with the seat, needs to slide in and out of that mortise, and a dowel sticking out would get in the way, obviously. Once the glue's dry, stick the 2 parts together, and bring it wherever you want a comfy place to sit, and pop a squat. And look at that, now you're the coolest parent at the soccer game. You're welcome. Look at all these losers. Their dumb folding chairs. And that's how you do it. And listen, I know you may not want or need a Viking chair, but this is useful if you want to cut anything longer than the rated capacity of either axis on your machine. All right, that'll do it for me. As always, I hope you found this helpful, and if you did, make sure to subscribe to the channel and don't forget to hit that notification bell so you don't miss the next video. Thank you so much for watching. Y'all be good.